Okay, the next differentiation rule that we're going to look at is the power rule. So differentiation is a fancy way of saying derivative. Okay, so power rule. If n is a rational number, then the function f of x equals x to the nth power is differentiable, and remember this means the derivative of some power function, so x to the nth power with respect to x will equal n times x to the n minus 1. For f to be differentiable at x equals 0, n must be a number such that x to the n minus 1 is defined on an interval containing 0. Okay, so what does this mean? So if you had some function, let's say we have f of x equals x cubed. That would be a power function. It's some function raised to a power. The derivative of that function, if we follow this rule here, first we put n. Well, 3 is n. We'll put n times x and then n minus 1. Well, n minus 1 would be 3 minus 1, which would be squared. This would be the derivative of x cubed. Okay, obviously this is the shortcut method. Okay, the definition of the derivative is this guy. As delta x goes to 0. Right? We definitely could go through that way, but that is definitely the long way. This is the shortcut way. Below here is the proof. So in order to use the proof, we'd have to review the binomial theorem. Then we would apply the binomial theorem to the power rule. Okay? And we would go through this process, and eventually we would be able to prove this. This is something that I'm going to skip for this course. I don't think it's really necessary to go through it for this particular proof. We will go through some of these proofs. This one's just a little bit on the harder end. It's something that's doable, but I'm going to spend more time doing other things. Alright, let's look at example 2. So, several different power functions here. This part A, we just did this one. This would be f prime of x equals 3x squared. Remember, the rule of f prime of x is n times x n minus 1 when f of x equals x to the nth power. Again, this is the power rule. We're going to have all these different derivative rules that you're going to want to memorize, so it's important to know the names of these rules. So when I refer to them, you know what rule I'm talking about. Okay, the next one, g of x equals the cube root of x. I would rewrite this as a power, so I'd rewrite this as x to the 1/3 power. Then when I find the derivative of g of x, that's going to be equal to n, which is 1/3, times x to the 1/3 minus 1 power. Well, we know 1/3 minus 1 would be negative 2/3. And this would be fine. You can leave your answers at negative x prime. Totally fine with that for calculus. Okay, part C. Y equals 1 over x squared. So I would rewrite this as a power. So I would rewrite this as x to the negative 2nd power. Then you could apply the power rule. So y prime would be negative 2x, negative 2 minus 1. So this would be negative 2x to the negative third power. Again, I'm fine if you leave it with the negative exponent here. Notice that I'm using the proper notation here, that I'm indicating I'm taking the derivative. I use this y prime. Same thing here. Okay, same thing here. It's important to use proper notation. Let's look at example 3. Example 3, find the slope of the graph. So we've got f of x equals x to the fourth for each value of x. So I want you to find the slope for each of these. So let's look at A. So first of all, I need to find f prime of x. So this power rule, once you have it memorized, it's pretty easy. Okay, it's going to be, for this one, it's going to be 4x to the third. To find the slope, okay, the slope of the tangent line is equal to f prime of negative 1, which would be equal to 4 times negative 1 to the third power, which would be equal to 4 times negative 1, which would be equal to negative 4. So there's part A. Part B, the slope of the tangent line, which would be f prime of 0, which would be equal to 4 times 0 cubed, would be equal to 0. Part C, the slope of the tangent line would be f prime of 1 equals 4 times 1 cubed, which would be 4 times 1, which would be 4.